All right, give you a little rundown on the operation and how to test a brushed DC motor. This is a 90-volt DC motor. Down here there are two poles where the positive and negative are. DC positive is going to come in from one of these brushes on this side, and there's pathways through this armature that are 180 degrees separated. So as the DC voltage lands on one of these commutator bars, it energizes one part of the stator, pushes off that pole on the permanent magnet back to neutral, back to ground, or DC negative, this brush. So that creates a 120 degree flux from the permanent magnet, pushes the rotor rotational force. As it spins, the commutator bar switches over to the next one, and the brush is able to touch the next one, energize the next stator bar, push off the permanent magnet, so forth. That's how rotation happens. So what we got here is you need to test resistance from one commutator bar to the other one, exactly 180 degrees apart. That's kind of difficult to do. So I got the end cap of the motor rigged up, both brushes touching. We're gonna measure with resistance as we spin it. Slowly spin it. The resistance should stay around. This particular armature is 3 ohms. So if it jumps up real big, probably got one of the copper winding pathways about frayed open, creating resistance. If it jumps real below 3 a lot, likely the insulation around the winding pathway is compromised, leaking voltage into the other. Everything looks good. Armature's good. Continue on.